Welcome to another exciting educational video brought to you by Upvision Concepts Academy. So today we'll be looking at the periodic table and periodicity. This topic is crucial because it helps you to predict the behavior of elements and understand chemical trend easily. Okay, so what are the concepts, the key concepts of periodic table? It's a table that is systematically arranged to have elements, in increasing ascending order of atomic number. So you are arranging elements by the number of the atomic number, how it is increasing. The concept of periodic table is actually was designed by Dmitry Mendeleev. He designed it initially by atomic mass, but now it's arranged by atomic number. That's the modern periodic table. So you have the horizontal, you have a table like this. I'm just going to draw a table like this. So you have the horizontal, and the horizontal is the period. This is the period. And the rows is the group, vertical. So this is group and period. So here I have elements arranged like this. You have periods, let's say period 1, period 2, period 3, and so on. Then you have group group 1, 2, 3, 4, 5, 6, 7, then 0. Okay, so you have the horizontal arranged in the period as period, or it's called a period, and the vertical is called the group. So the structure of a periodic table is that groups 1 to 18, the elements have similar properties. Okay, I'll explain why it is group 1 to 18. Okay, so period 1 to 7, the elements have increasing atomic number across the rows. The element has increasing atomic number across the rows. You have blocks S and F. These are block S, P, D, and F based on electronic configuration. So we'll look at these salient properties of the periodic table. So we go into the periodic law. So the properties of elements are periodic functions of their atomic number. So the atomic number here is key. It's very, very key. We are talking about periodic law. So the properties of elements are the elements, the atomic number is increasing. The properties of elements, become periodic. Periodic means that after some time you will see a trend. There's a group of elements that behave the same way because of the way they are positioned in the periodic table. That's what this periodic law is saying. So we're going to be looking at this trend to master. There are terms like atomic radius, I have it here, ionization energy, electronegativity, metallic and non-metallic character. These are the 4 things we're going to be looking at, but I have 2 on the board first of all. So actually, this atomic radius is known as the size of the atom. Atomic radius is known as the size of the atom. So actually, atomic radius is the distance between the central nucleus. This is the nucleus. I told you that the nucleus has both proton and neutron inside. Okay, so this is the nucleus. Let me call it nucleus here. Nucleus. Okay, and this is the electron. So this distance between the central nucleus and the orbit where the electron is the atomic radius. Understand? So, but the thing is that atomic radius decreases across the period and increases down the group. Why is it like that? The reason why atomic radius decreases across the period and increases down the group is because electrons are more tightly held across the period and more loosely down the group. Okay, now you see, across the period, more electrons are added at the orbit. For period, the orbit level remains the same. You have levels. This is let's say for instance, this is the central nucleus. This is level 1, L1. Another one here is L2. Another one here is L3. Let's just do it like that. These are the levels, orbital levels. Okay, now, if you are on a period is across the right. If you are on the period, this orbit remains constant because you have not changed to another one. You are on this orbit, but the electrons increases as you move. As the electron increases, the atomic size, atomic radius will reduce. Why? Because you see more of this attracting. That is, you have more electrons, and the attractive force between this side and this side will increase. So the distance between here and here will reduce. More electrons outside means that you have more negative charge to work on the positive charge, to try to come close. When they are coming close like this radius will reduce. So the atomic radius decreases across the period. As you add more electrons on this orbit, this same orbit, as you add more electrons, the distance between the central nucleus and the orbiter will reduce. That is the atomic radius. It will reduce. As it's reducing, you see that the trend will be there. Okay, so if you have the periodic table like this, for instance, now, normally I've not started telling you so you have hydrogen here, you have helium, you have lithium, you have barium, boron, carbon, nitrogen, oxygen, until you have this first, this first halogen here. Sorry, this first gas, helium gas there at group 8, group 0. Okay, so now at this orbital you have two orbital electrons, but this is what we are considering, the outer one that we are considering. So you have one for this first one. When it comes to this second element, there are two. So you see that the central nucleus and the two electron here will try to reduce the atomic radius. Then for this particular one, another one is added here. So you have 3, so it reduces. So the more electron that is added on a constant, orbital, the lesser or lesser the radius. So as you go from left to right, atomic radius reduces, but it increases down the group. Why? Why is it increasing down the group? Because down the group, you will have an additional shell. What we are looking at is the central nucleus and the outermost shell. So at this level, at P3, period 3, a third shell is added. So you see that the distance between the outer shell and the innermost nucleus has increased. So it decreases across the period and decreases down the group. Okay, now the next trend we'll look at in the periodic table is what we call ionization energy. What is this concept, ionization energy? Ionization energy is the energy required to remove a single mole of electrons from an atom in a gaseous state. So I want to remove one electron from the outermost shell. I want to remove one electron. Is the energy that is required. You agree with me that the more the shells you have, the lesser the energy that is required. You understand? The lesser energy that is required. So ionization energy increases across the period, but decreases down the group. Why? Because you have, as you are on the period, like this is a period. The period, as you go from left to right, more electrons are on the shells. If you have more electrons on the shells, it will require greater strength or greater energy to remove the electron. Why? Because you have more. And as you have more, those electrons tend to attract the nucleus. So it's difficult to pull it out. But if you are looking at group, down the group like this, because you have one shell added, the shell is farther than, away from the nucleus, and it's easier to remove, because the concept is that the energy, the binding attraction between the central nucleus and the electron has reduced. So if it has reduced while the thing is going down, while the shell are being added, it has reduced. That means the energy required to remove it will be less. So it increases across the periods and decreases down the group. So what you should be looking at is the energy level, the attraction between this and this, for ionization energy. You see that is energy that is required to remove, the mole of an electron from the orbit of a gaseous state matter. But if you remove it while you have many electrons on a shell, many electrons on the shell implies that they are on the same period, and from left to right across the period, it increases. The electron increases. As the electron increases, what happens to the energy? The energy that is required to remove it will also increase, because there are many electrons, so you require more energy to remove it. But as you go down the group, the energy will decrease. Why? Because you have just, the distance between the outer shell and the inner nucleus is great. Okay, so let's go into the next two properties or trend we're going to look at. So another property we need to study its trend in the periodic table is electronegativity. This is the word, electronegativity. What is electronegativity? It's the tendency of an atom to attract shared electrons in a bond. So if I have this again, this is the nucleus and this is the electron. So this is for period 1. If I have another one outside here, electron, period 2. This shell, I'm adding shells. This is the third shell. So this is period 1, 2, and 3. Now, electronegativity is the ability of this atom to attract electrons. So the more electrons you have on this shell, the more electronegative that particular atom is, or that particular element is. The more electrons that it has on its shell, the more electronegative that atom becomes. So this thing increases. Agree with me that across the period, as you go across the period like this, the number of electrons on that particular orbit increases. So electronegativity is very easy to know. It increases across the period, but decreases down the group. It decreases down the group because down the group, you just have fewer number of electrons down the group. No matter how you look at it, down the group, you have fewer electrons down the group. So it decreases down the group. The next one we are looking at is metallic and non-metallic character. Now, these metallic elements are elements that are found on the left and the center part of the periodic table. You understand? And the non-metals are found on the right. They are found on the right. So this is found on the left side of the periodic table and center, and this is found on the right. Okay. Now, having known this, you see that the metallic character increases down the group. It increases down the group. There are another kinds of elements. They are called metalloids. So, but that is actually at the center. Is along the, it's a zigzag. Example of metalloids can be boron, silicon, and what have you. Okay, so these are metalloids. So, but the metallic character increases down the group. So down the group it increases, but it decreases across the period because you are turning from metallic to non-metallic. So this metallic decreases across the period. For non-metallic, it increases across the period. You understand? And increases down the group. Okay. All right. So I'll just give you some group trend to memorize for the exam. So I'm trying to memorize some particular ones that come out. The group, there are groups that have name. They have name. For instance, I can come to say alkaline metals. Alkaline metals are found on the left part. So alkaline metals include lithium. Okay, let me take this off. Okay, so alkali metals includes metals like lithium, sodium, and potassium. So these are very reactive. These are very, very reactive. Very reactive. They are metals. They are found in the left part of the periodic table. So they are very reactive. Then you have the alkaline earth metals. Alkaline earth metals. Examples of alkaline earth metals is magnesium, you have calcium, and you have barium. Reactive, but is less than group 1. Okay, so these are group 1 elements, and these are group 2 elements. Okay, I will also encourage us to go and check the periodic table and see this, a very good diagram of periodic table. Check it and see how these metals are placed. A very good periodic table will label all these alkaline metals, alkaline earth metals, and give you the elements in it. So magnesium, calcium, they are very reactive, but they are less reactive than the alkaline metals. So this is group 1 and group 2. Now the next one is group 7. You have the halogens. Now the halogens are elements like fluorine, chlorine, bromine, and iodine. They are non-reactive metals. Non-metals and very, very reactive. Yes, non-metals and very reactive. So now look at this trend. These are metals are reactive on this extreme end, and these are non-metals in group 7 and non-reactive on that extreme edge. The last one is the noble gases. It's either a group 0, you can call it group 0 or group 18, anyone you want to call it. Noble gases. Example of noble gas is helium. Helium is a noble gas. Argon, neon, they are all noble gases. They are inerts. Inerts is non-reactive, very non-reactive. So these are the key elements you need to memorize, you need to know. Like I said, go and check out a good periodic table from the internet, anywhere, or trusted site, or your study materials. Get a very good diagram of periodic table and study this element. This is just to stimulate you to understand and to study. Okay, so I'm going to go into WAEC style questions for us to appreciate this topic. Okay, so I have this WAEC style question on the board, 3 of them again, that are related to this topic we just treated. The first one says, which of the following increases down group 1 in the periodic table? So you agree with me that we studied all these properties. Group 1, what happens to group 1 down the periodic table? Group 1 is from top to bottom, So from top to bottom, what happens? New shells are added, new orbits are added. So if new orbits are added, which of the following increases down the group? Okay, number 1, I have ionization energy. No, ionization energy increases across the period. So it does not increase down the group. Electronegativity increases across the period, but not across the period like this, but does not increase down the group. Atomic radius increases down the group. Why? Because more orbits are added. More orbit is added. If more orbit is added, the atomic radius will increase. Remind you, I said the atomic radius is the distance between the central nucleus and the outermost shell. So if you go down the group, you have additional shell being added. If, for instance, you are going down the down the group, additional shell are added. So if, for instance, you are down the group, you see that more shells added, you have more, the radius is increasing. So C is the answer. Okay. For number 2, it says the elements in the same group of periodic table have the same dash. So the element in the same group again is up to down, up top to bottom. Understand? So the answer is D, number of valency electrons, not atomic number. You see, elements in the same group of period have the same number of valency electrons, not atomic numbers, not number of electron shells, and not number of protons. So the answer is D. Okay, so which element is the most electronegative? The elements are elements that are the far right, not halogens, sorry, not inert gases, far right, and topmost. So I'm seeing 2 halogens here already, but this one has more electric because it comes first before chlorine. It comes first before chlorine. So A is the answer. Okay, so generally in this topic, I want us to understand the layout of periodic table. Like I said, go and get from your materials or textbooks the periodic table, study them from what we have just discussed. Study them, memorize periodic trends. I talked about atomic size, I talked about ionization energy, I talked about electronegativity and metallic character. Study them, know the special properties of groups. Groups 1, where you have the alkaline metals. Groups 2, where you have the alkaline earth metals. Group 7, where you have the halogens. And group 0, where you have the inert gases. Practice using the periodic table to predict these properties. So I hope this video has been informative for you, and I'd like to thank you for viewing.